the phantoms out. So let's get out our P. What is our parameter? We're looking at the proportion of records.
Financial records.
Oh, well, expenses, I guess, is what it is. Yeah. That begin with 1. All right. H, what do we think? Yeah, we don't care. So at this point in time, we need to decide. What are we looking for? The proportions that are greater than 30.301? Or are we looking for the proportion that are less than 0.301? Or does it not matter if they're less than or greater than, but what really matters is that it's different from 0.301? Yeah, so, yeah, that's right, exactly. So my null hypothesis is going to be that P is equal to 0.30. Are we asked to do a... yeah, it's P with the actual population. We're trying to make an inference about the parameter. Okay. And our alternative hypothesis is going to be that P is not 0.301. Okay. A, let's check our assumption. Let's check assumptions. It says the data comes from a random sample, right? Okay. Do we think that the sample is large enough, right? Is the sample large enough? So is this true? All right, so what was N? N is 300. Do we think that that's larger than 1/10 of all of their records? Yeah. It's reasonable to assume there are more than 3,000 records. It is, sorry, to assume there are more than 3,000. Expenses, right, is what we're really talking about. All right. Also, so this right here was S. Each trial is independent is assumed, right? the number from one is not going to affect the number from the other, right? But n, we need to check. The P, NP, and we're choosing phi, our parameter, right? So n is 3 times 0.301. Is that greater than 10? We also need to check if n times 1 minus p is greater than or equal to 10. And both of those are going to check. For sure. Okay, all conditions have been checked and met. And we might even just say that, just to be clear to a grader. Let's go ahead and say conditions have been met. So we can move on to the next part of the program. Problem. That's 2. And name the test. So we will perform a 1 sample, 1 proportion z-test. My bad. I was thinking about other stuff. For sure. But we just have 1 proportion. We're not. That's not referring to the whether it's a 2-tailed or a single-tailed. Okay. The reason why we're saying this right now is because we're going to learn about a bunch of different tests in the next month. And it's important to tell your grader what you're doing, they'll understand it better, right? So if you state the test that you're doing, they're going to understand your work better. They're going to be able to follow your process better if they know what test you're doing. All right. I am speaking with a Russian accent, I guess. We perform 1 test if I took the 1 out. We will perform. I missed the T. Let's come up with a test statistic. Our test statistic is going to be Z equals. Before I get to that, I really need to know what p hat is, right? So we took a sample of 300, and so it was 68. All the way back. 68, you're right. All right, so we found 68 of them, which is going to be. I need to get out my handy calculator. Alright, so at this point in time, rather than making a bunch of calculations, I'm going to go ahead and run the t-test on my calculator. That way I'll have my p-hat value, I'll have my calculated test statistic, I'll have a p-value, everything will be there, and then I can just kind of fill in the blanks as I go through the process. And I can look at my calculator and it'll just go a little quicker that way. So I'll go ahead and I can do this just hitting the calculator button, do this on the scratch pad. Then I'll hit menu, statistics. We'll go to stat test. And then we'll choose a 1 proportion z-test. Our p value is 0.301. So there were 68 successes. 68 successes out of 300 trials. And that's good. Our alternative hypothesis is good. All right. So right away now, where we can start to see where this problem is going. We got a very, very low p-value. That's very good, right? Well, or bad. So it's good for us for our hypothesis, but probably bad for the company if you put it in context. But what I was interested the most in right now is that p-hat value, which is going to be approximately 0.227. Yeah, I was like, that is not. Okay. 0.227. Okay. We're going to go ahead and calculate our test statistic, which is a z-value of our statistic minus the parameter divided by the standard deviation of the statistic, which again is kind of weird that we wind up using our parameter value in the standard deviation. It does indeed make sense. 0.301. 1 minus that, which is going to be 0.6. All divided by 10. Our handy dandy calculator has given us a value for that, which is negative 2.8. Yeah, 0.7. Okay. Let's obtain a p-value. So, what are we looking at for our p-value? We'll draw a picture of our normal curve. It's going to look like we are looking for a two-tail probability, right? So if you're going to your table to do this, you would find 2.807 on your negative 2.807 on your table, and you would multiply that times 2, right? Because they're going to be the same area. On your table, it's going to be a very, very small value, right? Extremely small. Okay. So what we're looking at here, so there's a picture of it. It's always nice to include so that they know that you're talking about a two-tailed test. And then we'll include some notation. We're looking at the probability that p is between Sorry, my brain is taking a nap real quick. We're just going to interpret this using z values. it's going to be much better. So negative 2.807, and we're going to use Z instead. And then we're allowed to just input our p-value, which is 0.005, approximately 0.005. We are going to make a conclusion, which is going to be to reject the null hypothesis, right? So we will reject. I'm not going to say any long. I'll save myself time. We're going to reject an H naught, and we could say at the alpha level of 0.05, right? If they don't give you an alpha level, assume your alpha level is 0.05. It's the most common. And now it's time to state our answer in context. There is significant evidence that the proportion of expenses that end in, or that begin in 1 is different from companies further investigate. Whoa.